Now that we talked about the most important phase, which is the poll phase, it is time to talk about the next phase after the poll phase. It's a very critical phase where we have control over it as users. We can schedule callbacks to be executed in that exact phase, right after the poll phase, right after I/O, and that's the check phase. Let's talk about the check phase. You see, everything about the event loop is about breathing, giving the node phases the ability to breathe, and as a result, we break down the execution of multiple large callbacks into smaller ones. So even though that if I'm reading a file and I can execute a callback when that file is read, you have to understand that that callback will be executed in the poll phase, right after the file is read successfully. Right? So you can break that execution, and we're going to learn in the last section that you can take one large callback and partition it into multiple smaller callback using the set immediate idea, which is basically how you schedule things in the check phase. Let's get started. So the check phase comes right after the poll phase, and if you understand the order, you know that if you do an I/O right after that, you can in that I/O schedule in the callbacks, you can schedule something to be executed right after that in the check phase. And we'll show at the end of the lecture, I'll show some examples of how you can use this phase to produce a predictable output. I know it's a little bit vague now, but trust me, it's going to become clear. So, check phase. This executes code right after the poll phase. So, example that you're reading a file or reading a socket, writing to a socket. Right after that, this phase exists, and this phase is solely designed for users, for us. You can schedule things in this phase by using this beautiful function that's called set immediate. So for example, if you know the poll phase is going to take a while, right? If you're reading something and it's going to take a while, it doesn't mean that node will block. It will just move to the next thing, because you don't want to ever block the event main loop, the main thread. You don't want to block that. Right? And node will do its best not to block, but the onus is on you, of course, as a developer, to also not block, right? But essentially you can give room for the rest of the scripts to be executed on another phase, like in this particular example, and use set immediate for that. So we're going to use the set immediate function to schedule the check callback, and we're going to use it to produce a deterministic outcome. Like, we know check phase execute after the poll and absolutely before. If you ever run a program, you guys, and you saw that outputs are different in Node, understand that you can, at certain cases, control how that output and make it consistent. And we're going to show how to do that. It's just because how the check phase exists right after I/O, the fact that you know that, you can force as an I/O and execute a callback right after that. So you know that, oh, I'm going to do an I/O and after that my code will execute. It's not going to execute before. And this is how you get predictable output. All right, so let's do an example here. So here we have a very simple program that reads a file and then calls a callback. And then it calls the set immediate, which just prints set immediate called. So if I follow in the initial phase, we initialize the function. We set this is just a variable. In the initial phase, I go to here. It says, hey, fs.read file. What do we do in the initial phase? We simply open the file, and we make sure the file can be opened successfully. So in this case, let's draw something. Yeah, let's draw. So we're in the initial phase, right? Initial phase, IP, right? We open the file. Then we go to the timer phase, nothing. Then we go to the pending callback phase, nothing. We go to the idle prepare, nothing. Now we're in the poll phase right now. Now we're right here. We're about to execute that. We're here right now. Okay, we're in the initial phase. We execute that. We open the file, and that's it. We don't do an actual read in the initial phase. We just say hey, and execute that, and hey, read file. Okay, I'm gonna schedule a read callback right here in the poll phase. That means we have two things to do here. We need to read the file, which we didn't do yet. So we still have to read the file, and we still have to execute the read callback. Remember, the file has not been read yet. Okay, we're still here. So we do this. We schedule the callback, which is not even ready. Now we're here. Set immediate. What do? It's the second phase, right after the poll phase. This is the check phase. And then we will schedule the set immediate right here. So now the initial phase is done. Boop. We go to the timer phase. Is there anything? No, there are no timers, no callbacks. Okay, move to the idle prepare. Is there anything to do here? Pending callbacks? Nope. We reach to the poll phase. Now we notice that there are two things to do here in the poll phase. What is the first thing? We need to read the file. And the second thing, we need to execute the callback. Well, you cannot execute the callback because we didn't read the file. So we issue the read. We do the IO to issue the read. Very nice. We issue the read. Now, if you build Node, you would do that. If I issue the read, that could be expensive, right? And if I issue the read and wait, that could be expensive. So what Node does is it issues the read, and it knows it's going to take time, right? So it just moves on. And in this moving on, that is the power of Node.js. You see how critical this thing, you guys. I issue the read and I move on. And I then immediately move to the next phase, which is the check phase, which happens to have a callback. Who set the callback? The initial phase, because we went through here, right? And then we found that, oh, set immediate. So let's print it. So what do we print first? We first print the set immediate called. After that, of course, we go all the way loop back. Of course, we don't go to the initial phase. Timers, no timers. And then by the time we came back to the poll phase again, the read has completed. And then we have the callback check ready. It's ready. The node marks that it's ready. So we pick it up and start executing it. Right? Well, if it was not ready, we'll just do another loop. And then we come back, right? Until the callback is ready. And that's the power of Node.js when it comes to non-blocking. See, if you didn't take anything from all these lectures, this is one of the most important ones, just to understand this loop, right? So critical, you guys. And I realize I've been covering the screen a little bit, but yeah, essentially it's just scribbles. So hopefully you were following what is going on there. But yeah, let's clear and let's go to the next page. And you see, start end, right? That's just start end is just me printing the initial phase start and the initial phase end. And then we have the set immediate called as I expected, and then read file. See, it's just this, then this. So the check phase was executed. It looks like the check phase executed before the poll, but that's not true, right? The poll phase did execute before, but it's just the cost of read file is expensive. So we delayed it, right? Until the next phase, until the next iteration, to be specific. And that is all when the file exists. So let's take an example where the file doesn't exist, you guys, to prove to you that here's what's going to happen. If the file doesn't exist, right, the output will be different. Look at this. if the file doesn't exist, we first do the read file callback followed by the set immediate. This is a proof that the poll phase is before the check phase. So why, right? Again, we do the initial phase, right? The initial phase goes, okay, loop, go through this, and then I understand this is covering it. So this is when the file doesn't exist. When the file doesn't exist, what you guys gonna get is we go through the initial phase. This is just registering the function. We initialize this also in the initial phase. We run into this fs read file. What do we do in the initial phase? In the main module, we just open the file and we discover that it doesn't exist. So there is no read to do, right? So immediately I'm in the initial phase. I go to timer, right? And then the other request, the phase, and then I'm in the poll phase here, P. While I am here, I immediately know that there is a callback that is ready to run. There is no read. So immediately we have a callback here, and that's ready. We set the callback. The initial phase just adds a callback to the poll phase queue and says, hey, go ahead and run. It's ready. Whenever you get to the poll phase, just execute it. Why? Because there is no read to do. The file doesn't exist. So there is nothing to read. So this is a very critical thing to understand because of the order of how do we do things. So now we add that. Okay. Now, next, what happens? We set immediate. So the next phase, which is the check phase, we add also another callback that is ready to be executed, of course. Do you see that? So now the initial phase is done. We move to the timer, nothing, nothing, nothing. We go to the poll phase. What do? Oh, there is a callback and there is nothing, no execution need to happen. There is no IO that needs to happen. We have just a ready callback. So we just print it. We print this output. And then after that, I'm done. I go to the callback, check phase. I print this. And that what gives us this output. Start end, then gives us the read file, followed by the set immediate. Isn't this cool, guys? I love this stuff. I love when something unpredictable becomes explainable by understanding the fundamentals, right? So, summary and demo. So what do we learn? We learned that the check phase is in lockstep with the poll phase. Okay? Poll phase, check. Poll phase, poll, check, poll, check. Always like that. So we execute code as soon as the poll phase ends or idles. Very critical, right? It can end, there's nothing to do, or hey, I'm idling. I just executed an IO. I'm just not gonna wait. I'm just gonna move to the next one, right? So difference, we talked about, we didn't talk about this. We're going to talk about right now. Difference between set timeout and set immediate is very critical. We're going to do it now, right now. Set timeout schedules callbacks to the timeout phase, timer phase, versus set immediate schedule callbacks to the check phase right after the poll, right? So there's order to things. So let's just do some exercises, you guys, I think we can do this in my Mac. I don't need my Linux machine because we're just printing stuff here. We're not gonna do any S-trace or anything. But yeah, let's execute the first thing here. All right. So what is going on here? We're fs. We're printing a start. We're read file. We're trying to read a file that's called test1.txt. As we said, the file will be opened in the initial phase. And then we have set immediate, scheduled, and then there is a large loop, and then we end. Isn't that cool? So what do we expect the output to be? Well, let's check, is test1 exist first? Right? Let's make sure test file exists, because this is a case where test must exist. Right, there you go. Test hello world. Yeah, So now if I do node 606.060 set immediate, and then we run, you can see that the set immediate is called first, followed by the read callback. Why? Because exactly what we said. We went through the poll phase. So what we do is we open the file, it exists, so we schedule the read file callback, and we also schedule a read IO. So we go to the poll phase, we send the IO, but the read file callback is not ready to be executed yet because the file has not been read yet. So we move to the next phase, we execute set immediate first. That's why we get set immediate first, followed by the hello word. If I do something that doesn't exist, this flipped. Now we have the read file first, followed by set immediate. Right? And we explained that, right? Because the initial phase tries to open the file, it doesn't exist, so immediately schedules the callback that is ready. Hey, we don't have anything to do. So the error will be populated in this case. And then, yeah, we just execute it immediately when we get to the poll phase, nothing to wait. And then we move on, and then we execute the check phase later. And that explains the different output. Okay, let's do a timer. If you do something like that, these are two calls. One is set timeout to print timeout with a 0 millisecond. And then one is set immediate, which prints set immediate. What is the output here? The output is completely non-deterministic. And you know why, right? Because when I put that thread to sleep, when I talked about the timer phase, there is absolutely no guarantee that this will wake up in the first iteration, right? The libuv will, there's no guarantee that the kernel will wake it up right after the first iteration, because it could be delay, context switching, and as a result, what you're gonna get is an unpredictable result. Sometimes we will be lucky and the timer will be waking up first, and we're gonna get timeout immediate. Sometimes no, the timer will be delayed. Right, we will miss. Do you remember when we did the timer? There's always like 1 or 2 millisecond delay in certain cases. So in that particular case, you're gonna get immediate timeout. So let's print. Let's see where we get. 6.1. In this case, we got immediate timeout. Immediate timeout means the timer was delayed. And after a few tries, you can see that timeout, immediate timeout. So it depends on how slow your machine is. This is like pretty fast machine. So, but there is some chance that you can get timeout immediate. So it's not predictable. That's what I'm trying to get at. And that's why you can do something like that. And you might have seen this in the doc. This is one example is in the doc. I just took it from there. But now you can look at this and you completely understand how it works. And you have no shadow of a doubt why it works the way it is, because now you understand the loop, right? Let's go through it. So what is happening here? In the initial phase, I, of course, load this fs, and I have just one thing. I'm reading a file, and I'm scheduling one callback. You see? And that callback, where does it go? Right, the poll phase. This goes to the poll phase. If I go to the poll phase, and it depends, is it ready or not? That's up to the read file, right? Technically, file name exists, right? Because it's the file that we're running. So when I get to the poll phase, initial phase and finish quickly, right? There's nothing to do. We schedule just this callback, and it's not ready because we need to read the file. So there is a read that needs to happen and a callback that is not ready. We get to the poll phase. Why do we do the poll phase? Well, in the poll phase, I need to issue the The read. So we do the read. We go to the check phase. There is nothing. Right? And we come back to the timeout. There is nothing. Why are you saying there's nothing? Yeah, because we never executed this code, you guys. Remember? Because that have never run. This callback has never run. So the second iteration, perhaps the third, depends how large this file. We go to the poll phase, and now this callback is ready. We execute it. We set a timeout, which gets added to the timer phase, which is before me, right? Before the poll phase. And I also get another callback that is in the check phase, set immediate, right after me. So I am in the poll phase. I scheduled something in the timeout and something in the check phase. Now, what comes after the poll phase? Is it the timeout? No. What comes at the poll phase is the immediate. So we always gonna print this, because when you set something as immediate, it's ready to be executed. There is no like, you don't have a state that a set immediate and the callback is not ready, right? Unlike IO. Like in this particular case, if you read something, the callback has to be marked as ready. Just like the timeout has to be marked as ready, because the time has to be elapsed for the callback to be ready to be executed. Right? This here is just like, hey, it's ready. So always you're gonna get immediate timeout, immediate timeout, immediate timeout. Right? And there will be enough delay from the immediate timeout, from the check phase to the next phase, which is the close event, up until going back to the timer. So you will get immediate timeout. And if you somehow missed it, the next loop will pick it up, right? So you're always going to get immediate timeout. That's what I'm getting at. Node 06062. If you try running this forever, you'll never get timeout immediate. It's always going to be immediate timeout, immediate timeout, immediate timeout. Predictable. And not because someone told you so, because you know the facts, right? Now you understand. And you can play games. What happens if this file doesn't exist, right? You just make this faster, I suppose. That's the only difference. If the file doesn't exist, you execute the poll phase faster, and as a result, you get the results faster. Right? That's the only difference. All right, that was the check phase, right? And we're gonna be referencing this a lot, you guys. So stay tuned.